can we produce unlimited clean energy to fuel the planet? Can we create artificial prosthetics to improve lives all over the world? And how do we make the world a safer place for humanity? These are just a few of the questions that LLNL is trying to develop solutions to every day. LLNL is one of our nation's 17 national labs, and ours is located just 60 miles from San Francisco. For decades, Lawrence Livermore National Lab has led the development and application of the innovative science and technology that our nation needs. We apply this innovation to challenges of national security, international stability, human progress, and so much more. Livermore was founded as the New Ideas Lab and still lives up to this reputation today with our intellectual leadership, originality, and audacity. Programs like the National Ignition Facility, Global Security, and supercomputing initiatives demand that we draw on the widest possible diversity of talents, thoughts, and backgrounds, people just like you. Our incredibly wide array of disciplines, from computer science to engineering to physical and life sciences, all come together here at the lab to help our nation lead the future. With cutting-edge technology in additive manufacturing, the world's most powerful and energetic laser, and one of the world's most powerful supercomputers, our teams apply frontier science and engineering to deliver solutions to the nation's problems. And along the way, we serve the public interest and sustain public trust through transparency, honesty, and objectivity. We have a driving passion to excel, lead, and ultimately, to change the world. And as an institution, the lab is a place where people find great fulfillment in their work. Work-life balance is ingrained into our culture, and we provide flexible work schedules and recreational opportunities on-site through our many activity groups, on-site fitness options, and wellness resources. And that's because we believe that aha moments don't always happen at your desk. The lab will continue looking to researchers with big ideas from a variety of disciplines to help unlock and solve some of the most interesting challenges facing both the nation and the world. Just think, what problems could you solve at Lawrence Livermore National Laboratory? Scientists, technicians, engineers, and staff explore the science of nuclear weapons in a lab setting. This includes the work we do at the National Ignition Facility, or NIF, the most energetic laser in the world. We use it to recreate and measure key types of nuclear interactions on a tiny scale in a safe and controlled environment. Another essential tool we have are some of the fastest supercomputers in the world, which run simulations on the questions we're asking about the nuclear stockpile. The code that goes into those simulations, written by our world-class scientists, engineers, and software developers. Those simulations are then compared to the data we gather from experiments, like the ones done at NIF. Then we can refine the models and code into an accurate predictor of reality. But all of this research doesn't just apply to nuclear security. The scientific expertise, experimental capabilities, and computer simulations we develop for stockpile stewardship are put to use for other national security missions and important scientific fields, like identifying and treating traumatic brain injuries, predicting and mitigating the effects of earthquakes, or understanding what the inside of stars might be like. We also work with partners to develop better ways of identifying and stopping potential threats around the world.
Behind me, you can see common equipment that one would find in a typical transmission substation in a power grid. These devices enable us to see how these cyber attacks would actually behave and then replicate that behavior in modeling and simulation. To do this at larger scale, we actually need much more computing power. So basically, modeling one substation is not a big deal, but modeling the whole California network of both power flow and communications that are enabling that power flow actually requires high performance computing capability. And here at Lawrence Livermore, we're able to connect our physical testbed with our modeling and simulation capability, and then use high performance computing to see how these effects would propagate at scale.
New national security challenges call for new national security solutions. Livermore, along with UC Berkeley and Sandia National Lab, collaborated to produce an award-winning game that helps students and researchers understand nuclear deterrence, strategic stability, and conflict escalation dynamics. For more than 50 years, Lawrence Livermore National Lab has provided technical support for international treaties and agreements that limit or ban weapons of mass destruction. LLNL's gas transport simulation and detection efforts are transforming national capabilities and setting a new stage for policymakers to monitor underground nuclear explosions. Applying new theoretical developments in nuclear fission chains to detector technology, LLNL researchers have developed powerful new tools that will enable them to detect and assess whether unknown objects contain nuclear materials. For decades, the lab has been a leader in developing, fielding, and commercializing systems for nuclear materials detection and identification. LLNL scientists lead national and international efforts that have defined the field of nuclear forensics. Lab experts are teaching the world how to survive a nuclear attack. The lab developed a software-based tool called Network Mapping Systems, or NEMS, to provide network owners with a comprehensive view of their computer network environments. A NEMS scan can reveal valuable information such as misconfigurations and other system errors that might make a network vulnerable to attack. The Cyber Defenders LLNL Summer Internship Program provides hands-on training for students from a variety of backgrounds to work on real-world cyber problems. Under the guidance of lab mentors, the students develop skills that include intrusion detection and prevention, network monitoring and analysis algorithms, anomaly detection, and machine learning. Livermore scientists produced the first diagrams illustrating U.S. energy use in the mid-1970s and continue to serve up energy analytics to industry and policymakers. Lawrence Livermore National Lab participates in every major commercial carbon sequestration effort worldwide. We integrated satellite, subsurface, and production data to quantify risk and provide operational decision support for the carbon capture sequestration facility in Algeria. LLNL researchers are mapping fossil water aquifers, which were recharged more than 12,000 years ago, to help managers decide whether groundwater can sustainably meet future demands. The LLNL Forensic Science Center has brought numerous innovations that have advanced law enforcement capabilities and solved tough cases. Lawrence Livermore National Lab is using 50 years of experience with military and commercial explosives to characterize improvised explosives that could be used by terrorists. Using additive manufacturing, LLNL is advancing the ability of canines to detect potentially explosive objects. Machine learning models are being developed by LLNL scientists and run on high-performance computing clusters to aid in data-intensive COVID-19 drug discovery and pandemic response efforts. A multi-institutional team of researchers, led by LLNL, has developed a smart, breathable fabric designed to protect the wearer against biological and chemical warfare agents. The lab partnered with private industry to mass produce a simple mechanical ventilator developed for COVID-19 patients. The ventilator has been authorized for emergency use by the U.S. Food and Drug Administration. Since 1989, the Program for Climate Model Diagnosis and Intercomparison at LLNL has been analyzing and diagnosing the performance of the world's climate models. When California's SCU Lightning Complex fire broke out in August 2020, volunteers with the lab's Community Emergency Response Team played a key part of the emergency response effort by staffing a hotline that provided residents with critical safety information. A team of lab researchers has used supercomputers to simulate a magnitude 7.0 earthquake on the Hayward Fault, which can inform seismic risks to buildings, homes, transportation, and utility lifelines. We are 1 square mile of the world's smartest people, making the world safer. Come and build a future with us.